Good evening, everybody. My name is Peter Marcham, G3YXZ, Chairman of the Radio Society of Harrow. A very warm welcome to you all once again to one of our very popular presentation evenings. Tonight, we're very pleased to introduce you to Dr. John Rogers, Mike 0 Juliet Alpha Victor, who is the EMC Chairman of the RSGB. Tonight's presentation is titled EMF Changes and What We Need to Do. So without any further ado, over to you, John.
Okay, thanks very much, Peter. It's nice to make contact again with some of the people in the Radio Society of Harrow. I know a number of them, although I can't see who's actually on tonight, but hopefully you can see the slideshow. Can you confirm, Peter? Yep.
Yes, I can.
Okay, so this presentation has been given a number of times and keeps changing as we move forward. But basically, Ofcom held consultations in February and November last year, and the RSGB responded along with a number of other amateurs, and we are in continuing discussion with Ofcom on the actual implementation. So all amateurs were informed by Ofcom of the change in March 2021, and it actually became effective on May the 18th this year. So the presentation outlines some of the ways you can assess your configuration and how you can record compliance. The most important thing to remember is that you don't have to do it immediately. It's a good idea to get started and see what's involved. But as some of the methods for doing the assessments are being refined, Ofcom have allowed between 6 and 18 months for you to actually have to do all these assessments. So, what is the new license condition all about? Electromagnetic energy can be absorbed by the body and it causes a temperature rise. That's the main thing. Our bodies are very efficient at removing this excess heat. We can vary the blood flow, we can sweat, we can pant. But if the rate of heat generation exceeds the body's ability to remove it, and there is prolonged overexposure, this can lead to harmful effects. So to encompass this, there's a body called ICNIRP, the International Commission on Non-Ionizing Radiation Protection, which is principally thermally based effects, and that specifies a specific absorption rate, which is measured in watts per kilogram. That is quite difficult to measure. So what actually happens is that they convert it into a reference level. So the basic restrictions is about the amount of energy that is absorbed by the body to raise the temperature. Reference levels are field levels which can be measured because it's quite difficult to actually measure the heat rise in a body that's alive without doing any harm. So you have reference levels, they're the corresponding field measurements. They happen for two different things, for occupational usage and for general public usage. And there are two types of exposure. There's local exposure, say to the head, and whole body exposure. And there's also something called electrostimulation or tingling nerves. And that electrostimulation is a peak effect. So you have to take three types of measurements or predictions: peak, 6-minute average, and 30-minute average. And that's what ICNIRP have wrapped up into guidance. So it basically comes down to something that's really quite simple. When you're transmitting around your aerial, you have an exclusion zone. The shape of that exclusion zone will vary with your type of antenna, and outside of the exclusion zone is the compliance zone. The size depends on the transmission parameters, etc. We'll explain that a bit later. But the general public can be in the compliance zone outside the circle, but the exclusion zone is where the general public should not be. So your job as an amateur is to work out what your exclusion zone is and then make sure you don't transmit if a member of the general public is in that exclusion zone. So this is the most important message of the night. If no one is present in an area when you transmit, then no exposure occurs, so you can't do any harm. So how does ICNIRP display this? It's like many technical documents. It's a 41-page guide, very comprehensive. For the mathematicians amongst us, you may like to see some of the maths. Looks quite complicated, but what it's saying is find the maximum of the electric field in relation to the limit and the magnetic field in relation to the limit, and find that for each of the frequencies you're transmitting on at the same time. And there are different types of limits as you go up in frequency. There's one set of formulae for greater than 6 minutes, another for less than 6 minutes. But I'm pleased to tell you that ICNIRP calculations are all done for you. And what you need to do is to compare your results with either tables of known results, or use one of the calculators, of which there are at least 2 tailored for the Ofcom regulations, or you can do detailed modelling, providing you can convince yourself and Ofcom, if necessary, that your models are accurate. So basically, the electric field is measured in volts per metre, the magnetic field in amps per metre, and S, which is the power density, is measured in watts per square metre. So let's have a little bit of a look at what these limits look like. So these are the limits of reference levels. So if your field strength is not greater than these limits that come up, then you are compliant. So what you need to do is to compare the electric field, magnetic field, and/or power density with maximum exposure levels to determine if you're compliant. But that is done for you. There is a graph which looks complex, but it's got everything on it. So the blue are the magnetic field strengths, and if you remember, I said there were 2 types. There was local exposure, which is shown by a dotted line, and whole body exposure, which is shown by a solid line. The whole body exposure has to be calculated over a 30-minute average, the local over a 6-minute average. So here we have the electric local exposure field. Here we have the magnetic local exposure field, and they are measured in either volts per metre or amps per metre. One thing that changes in ICNIRP 2020, which is what the final version will be at the moment, you can either use the limits in ICNIRP 1998 or ICNIRP 2020. But the big change in ICNIRP 2020 is the inclusion of electrostimulation levels. And these electrostimulation levels are 83 volts per metre and 21 amps per metre. And they are considerably lower. If you imagine these lines continuing straight on, you can see that the 2020 levels are considerably lower than they would be because of the inclusion of electrostimulation or peak field measurements. The other thing to remember is that these are peak fields and all the others are average. When you get up at the top end, you don't have to worry about the individual E&H fields. You can just take the power density. So from 2 gigahertz up to 300 gigahertz, it's 10 watts per square meter, which is quite easy. So that's what they are requiring be done, that you estimate by modeling your fields and then you compare them with a limit, and at a certain distance, that limit will give you an exclusion zone. So a lot of that, I wanted to explain to you what was behind it all, but this is the part that you need to understand, because this is what you've got to do. So it's being simplified down to a 4-step process, and currently the version that is of the guidance document has been withdrawn and is being republished in a simplified form. So next week sometime, hopefully, the guide to amateurs will reappear on the Ofcom website. So the first step is, do I need to comply? And if you're not using your radios anymore, or you only use them in bands that are allowed less than 10 watts EIRP, then the answer is no, you don't need to comply and you're finished. If you are using your radios properly, then you go on to step 2, where you carry out a compliance check. And this compliance check will allow you to define the exclusion zones. You can either do that using Ofcom compliance tables, which are being prepared, which will give you typical configurations and tell you what the compliance distance is. So as long as the general public are not closer than the compliance distance to your antenna, then job's done. Or you can use the Ofcom EMF calculator. This requires you to type some numbers in, and it gives a single compliance distance. Fine. The big advantage of using the Ofcom calculator is that they're not going to argue with their calculator. So if it gives a result, then it has to be accepted. We tried to help amateurs by producing an RSGB EMF calculator. It uses the same calculation engine as the Ofcom one, but it includes many more factors. It includes transmission modes, feeder losses, antenna gain, directivity factors, and whereas the Ofcom calculator gives you a linear distance, a 1D measurement, the RSGB calculator can be used to build up a 2D exclusion zone by feeding in directivity factors. You can also use any other approved calculator or any modelling you can do, providing you're confident that it's accurate. To help you with this, as some of the setups can be quite complicated, we have a team of experts from the UK, RSGB and the ARRL who work on this as part of their life. They write standards and that sort of thing. So we've got 7 experts and they're doing the calculations, and we're publishing these as what we call pre-assessed configurations. Pack 1 is on our website, and the advantage that they have is they give 3D exclusion zones, and I'll show some examples about that in the near future. Having found what your compliance exclusion zone is for the current setup with the current power, etc., then what you need to do is manage compliance, and that basically means making sure no one is present in the exclusion zone when you transmit. Having done step 2 and 3, step 4 says keep a record, and as you'll see when we come on to our spreadsheet that we produced, that, you know, if you actually take a snapshot or print to a PDF or take a screen grab and save that somewhere, then that is an adequate record. I've had a couple of complaints that people are printing all of these different configurations out and it's using up loads and loads of their ink. And I said, well, don't print it then, just take a snapshot. There's nothing that says it has to be a printed record. And these days, most of us have our licenses by email anyway. So, okay. So in a broader sense, away from the simplified amateur guidance, there is another guidance document for all spectrum users, and that identifies 4 different methods of showing compliance. The first one is to use a calculator or desktop calc. Second is to use manufacturers or installers' guidance or instructions. There aren't too many of these at the moment. Some manufacturers are doing it for radios, but for some of the other spectrum users, and bear in mind that This license change is going into all 300,000 UK Spectrum user licenses. This is the big way of doing it. And I suspect in time, handhelds and other types of radios will come out with guidance from manufacturers, and following that guidance will be sufficient for you to be compliant. You've got establishing consistency with the packs again, and taking measurements. We are not recommending taking measurements as a first step because it's quite complex. The measurements have to be of the unperturbed field, and of course, as soon as you stand in it, you perturb it. So you have to have a remote accessible instrument, and you also have to follow a documented procedure. This really is intended for professional users rather than amateurs. So you must, again, of course, I've said this so many times that you should all know, you must make sure that there's no one in the exclusion zone where the levels are exceeded when you're transmitting. Now, for a lot of users, like the BBC, of course, they transmit all the time. Whereas with an amateur, if you see somebody walk into the exclusion zone, key down the mic, and you're still compliant. Keep records of what you've done, and if possible, when you set up a new station or a new configuration, have a look at pre-assessed configurations, do the calculations, and choose the optimum configuration to be compliant by design before you actually build it. This is a view from Ofcom in their higher level guidance document. It contains everything, but as I've shown you, they've simplified that down to 4 steps for the basic guide for amateurs. Now, what's this all about compliance distances? So what I've shown here is an antenna on a mast with its main beam pointing in the direction of a person. The compliance distance for the simple calculators is the nearest point of the antenna to the nearest point of the person. That can be calculated or separated into vertical and horizontal separation. The vertical separation is quite easy. It's the antenna height minus the height of the person, and we tend to use 1.8 meters. The horizontal separation is whatever else you need in order to get the compliance distance. But of course, most antennas are directional. So the main beam gain that the Ofcom and the basic RSGB calculator uses is only true on the bore side or in the heading. So if you're off to the side, then you need to reduce the gain of the antenna gain factor, by a factor to take account of the fact that you're off the side or you're in the elevation load. Now, the RSGB calculator cannot do this in all of its complexity, but a lot of the modelling work that we're doing will give you those answers if you need them. So what we recommend is you use the simple things like the calculator first, look at your compliance distance. You might be surprised to find it's only a few meters, 4 or 5 meters, and therefore you don't have to worry about being compliant. If, however, you've got a very powerful beam and you're pointing, then you may need to take care of how the field strength changes as you go off that bore site. And the pre-assessed configurations that we've developed will give you 3D exclusion zones, so you can calculate not only at an angle in azimuth, but you can also take into account where the exclusion zones are in height as well. So let's have a quick look at one way of doing step 2. We're going to choose our own calculator as the way of doing it. And I'll go, when I've finished the presentation, I'll put the calculator up and try and give you a demonstration over the questions. So basically, what the calculator does is it asks you to fill in the yellow squares. So you need to choose the band you're operating on, the mode you're using, the power you're transmitting at. And how much of the time you're talking. If you talk half the time, it's 50%. If you are on a contest, it's probably 95%, if you're holding the frequency. It then takes the average and peak power that comes out from the transmitter, and all of our tables are in both linear units and dB units, because some people prefer to work in one and some in others. You then look at the feeder you've got, so you can choose your feeder type, enter your feeder length, enter any other losses like connectors, etc. that you've got in. And what you'll get then is the amount of power that is now coming out of the feeder into the antenna. You select the antenna type, and that will give you the gain in dBi, which appears in here. You select the height and any directivity factor. And in this case, the first thing you notice is a message pops up saying you are compliant as less than 10 watts EIRP, and as of the next version of the calculator, and less than 100 watts, 10 watts EIRP average, and less than 100 watts EIRP peak, because that's a change that's just gone in. So, as I've said, you need to specify the parameters of your setup. It derives the average power, calculates the separation. I'll show you where that appears in a moment. And as long as you keep people out of the exclusion zone, you will be compliant. The calculator is conservative. What that means is not the way it votes at an election. It means it gives a number that is bigger than the true number, so that you will not be non-compliant. This is what the full screen of our calculator looks like. The beige boxes are where you can enter details of your configuration. The yellow boxes we've been through. If you have a setup like this example, where we're not below 10 watts EIRP average and 100 watts EIRP peak, then the calculator will give you a compliance distance, 3.6 meters in this case. But fortunately, as your antenna is 5 meters high, you've already got 3.2 of those meters just in getting down to the ground. 3.2 plus 1.8 equals 5. So if you use Pythagoras, then you can calculate the horizontal separation is 1.6 meters. So on the 20 meter band, pumping out 400 watts, SSB processed into a half-wave dipole, and I need to stay 1.6 meters away from the shadow on the ground of the antenna. For the general, I need to keep the general public that far away. So I don't think that's too difficult. If we look next at the way that we do the pre-assessed configurations, then the first thing we need to consider is the individual fields. So the electric field, as you would expect, the black line is the dipole antenna, inverted V. As you would expect, the peak electric field follows the peak voltage, which is on the end of the antenna. Whereas by comparison, on the magnetic field, the peak magnetic field follows the peak current, which is in the middle of the antenna. If you put those together and do some maths, which includes averaging over a space a person would occupy, because you've got to calculate whole body absorption, then what you see is what we call the compliance zone for 10 watt, 100 watt, 300 watt, 400 watts. Anywhere outside of that contour, the field is low enough for a person standing at ground level or at whatever level you are at, not to receive energy above the ignorant limits. The first thing you notice here is how the fields are much stronger below the antenna than they are above the antenna. The main reason for this is when the antenna radiates, it reflects off the ground. So all the different parts of the antenna are reflecting back off the ground. And also any ground currents will re-radiate. So let's look at some exclusion zones. I show you the picture previously, looking at it sideways on in the vertical plane. At the same time, you can look straight down. So here we have X and Y, and what we see is a bow tie of compliance distances. And I point out that the biggest distance on here is 2 meters, plus or minus 2 meters. So what you can do then is to simplify that diagram, because this is for a resonant dipole. You can simplify it into a series of rectangles. The middle black one is looking down at the antenna. Then the brown boundary is 0.5 meter away, and that's the 10-watt boundary. The red one is a 100-watt boundary, which is 1.1 meter away, and the blue one is the 400-watt boundary, 2 meters away. Now, if you remember, the calculators are giving you 3 or 4 meters, which I said was conservative. But, you know, if you can live with 3 or 4 meters as a separation, no problem. If not, then you need to choose the appropriate pre-assessed configuration, look at the data, which is a bit more complicated, and just record that. So this is the first example we've given of how you look up the pre-assessed configuration. So I talked about depending on reflection from ground. So the ground model that's chosen in this case is any except it's not at sea. The V angle of the dipole affects it. So for any V angle, and what does that mean? That means we've done 2,700 models for all different V angles and chosen the worst case, so that you don't have to worry. You can do if you want. We produce tables of the detailed ones, so you can choose the one that's specific to you if you want to, and you might save another 30 centimeters or so in your exclusion zone. So if we look at a typical example for up to 100 watts at 80 meters, 3.6 meters will be compliant for any ground, any V angle, which isn't that difficult to achieve. We also recommend a minimum separation of 2.2 meters. This is not an Ofcom requirement, but we recommend that to prevent anybody touching an antenna, because you are supposed to take precautions against touch currents as well. So having got your distance or your zones from your calculators, your tables, or your pre-assessed configurations, the next thing you need to do is to work out where the public can be near your antennas. If you produce a sketch of your garden and work out what is accessible and what you can stop people getting at, you can determine the compliance distances using a calculator, and you can draw these exclusion zones on your sketch map. And remember, the most important thing I've said about 30 times already is that the limits can only be exceeded when somebody is or can be expected to be present when transmissions are taking place. Identify your accessible areas and exclusion zones, particularly where they overlap, and record these along with how you're going to make sure nobody goes into your exclusion zone when you're transmitting. So let's just have a look at somebody doing this. So if you go onto Google Earth, you can get a plot of the area around where you live. So here you can see a leftover mast. Over here is a VHF mast. And you can, if you want to find out how far accessible areas are away from you, then you can use Google Earth. So what I've done here is I've drawn a line from the antenna to a public footpath, but that is 22 meters away. admittedly, people could walk off the path, walking a dog, and come in to about halfway, but beyond that is dense vegetation, lots of brambles and nettles and goodness knows what else, specifically placed there to discourage people. And one of the acceptable barriers is vegetation, so you can do that too. So you can measure your distance, you can define your exclusion zones, work out where they overlap using the internet, Google Earth, Google Maps, etc. And then all you've got to do is make sure nobody is there, which you could do in this case by putting a PIR detector on the boundary. And if anybody came into that region, they would trigger the PIR detector, or you could put a camera there, or you could keep an eye on it, depending on your own particular configuration. We've done the same thing, and you can find these on our website, www.rsgb.org/EMF. We've done the same thing for a 40-meter dipole, and here we've decided we only need to show half of the antenna pattern because it's mirror imaged. And you can see that in this case, for a 40-meter dipole, hey presto, again, you need to be 2 meters away. And if you look at that, a combination of looking sideways and down, then you can represent it by this very simple diagram in which the red zones are where the levels would be exceeded at ground level. The amber zones is the recommended exclusion zone, and the green zones is where the general public can be without receiving exposure to levels of EMF above the ICNIRP guidelines. You can do the same thing for 2 meters, and this is where sometimes it's useful to think about the directivity factor, which I've spoken about already. In this case, we put in a 2 dB drop for the, we're up at 2 meters now, so we put in a 2 dB drop for being off the elevation main beam, and that reduces or produces a required horizontal separation of 2.4 meters. The compliance distance is 6.7. The antenna's up at 8 meters already. So when a mast-mounted beam is used, you can do what I've just described to calculate the directivity and therefore where the exclusion zones are. These are the records you need to keep. Basically, it's what you've done to do the assessment and what you've done to prove that you are managing the exclusion zones from that assessment. So good practice, aim to be compliant by design, follow the guidelines, follow the advice we put on the website, use one of the approved calculators, manage the exclusion zones, and if compliance isn't demonstrated, then just go around again and reduce the power a little bit or revise the mitigations until you do demonstrate it. This is the bit which we wait to see whether it comes true, but Ofcom say they want to foster a climate of compliance and not a high-handed enforcement approach, but they would act against reckless individuals. And before I take questions, I must thank a couple of the guys in the EMF team, particularly Ian in white, GM3SEK, and Peter Zollman, G4DSE. They are the gurus on this who've done a lot of the work, particularly on the pre-assessed configurations. So, they know a lot more about this than I do. So, any questions?
for a few minutes, whilst give you some thinking time, and then if you'd like to then start providing us with questions in the flowchart. One. Okay, John, can you hear me?
I can.
Right. Okay. So I'll take them. Okay, I've got the mute off. Are you ready for me to go? Okay, fine. Thanks, Kurt. Okay, we've got a few questions coming, ladies and gentlemen. First one from Stephen Waters. Good evening, Stephen. What happens if you live in a flat or similar shared residence, or go to your local park? For instance, would you need to wave red flags around?
Well, one of the ways of doing it is to provide a warning of a barrier. But if you go to your local park and you're operating a typical portable configuration, which is not going to be that high in watts, then your exclusion zone, as you can see, I hope you can still see the shared screen. The exclusion zone is only 3 meters. So if you keep an eye on people who are within 3 meters of your antenna, at sort of 20 watts on 20 meters, you've got no problems. But you don't actually, at this sort of level, need to have any compliance separation, because your power levels below 10 watts EIRP average and 100 watts EIRP peak. If it's a flat that you're in, if you can operate in this mode whereby you are low power compliant, as it's called, then you're okay. If you've got people in the flat next door, generally they're likely to be a few meters away, and you can set up your configuration so you're compliant.
Okay, thank you, John. One more question from Stephen Waters. Sorry?
Can you see my screen that I'm talking about? Or?
Yes, I can. Yeah. One more question, second question from Stephen. Where is the proven risk from ham radio emissions?
I don't know that there has been anybody who has suffered harm from ham radio emissions, but there are proven risks which are used in ICNIRP for medical cases where overexposure to radiation can cause health effects, but there is, I know of, no record of this ever happening from amateur radio, and let's do this job properly and keep it that way.
Okay, next one, John.
Yep.
It's from G8YTZ. Sorry, I haven't got your name, but thank you for your question. I'm interested to know about all those council residential blocks with large cellular installations. Presumably, are they going to have to go through the same?
Yes, it was because of 5G and people's concern that Ofcom were forced to actually make all licensed users, all 300,000 of them, comply. So the BBC has to do it. At the moment, every license has a condition in it which says that if you transmit above 10 watts average and 100 watts peak, then you must do an assessment and you must manage your installation to that assessment. So the short answer is yes. The other interesting point is that license exempt are going to be caught up later by Ofcom because they're going to be put in conditions in the license exempt users, which are equivalent to ensure that they stay below these levels, but they're doing the licensed users first.
Just a comment from myself at this point. I've noticed that all the power levels are quoted in isotropic radiation, effective isotropic radiation. Is there any particular reason why they've done that rather than conventional relative to a half-wave dipole or a quarter-wave vertical?
The new version of their calculator will actually allow you to use either, and they give you, I'm not allowed to show you this, but you can see that they allow you to use EIRP and ERP, and they tell you how to convert from dBi to dBd. But that's the next version of the Ofcom calculator, which is due out next week.
Okay. The next question from Stephen Waters again. I think you've actually answered this just now because you were talking about non-licensed systems having to become compliant. He says our CB radio operator is going to be compliant. He's got ones local to him who are running over 400 watts.
Well, that's illegal anyway, so they could get prosecuted. The as I said, license exempt will have a requirement, but they're only allowed to operate at low power, 12 watts, I think it is, isn't it, for SSB?
I forget now. Is it 13 or something like that? Can't remember. I don't have any other questions come through, Kirk, unless there's some others running there at the moment. I can, unless you want me to bring up the YouTube screen and read them off the screen for John.
I'll read a couple more out.
Okay.
Hello everybody, it's Kirk. John, could you show us how to use the calculator again just quickly? There's been a couple of questions of people just asking for that.
Okay, well, I've got the calculator up. So if I go and fill it in, so I fill in my name, I fill in my call sign, and any other details about the date, the station address, the radio type, etc. Which band do you, Kurt, want me to use? Name a band.
I saw a question about 80 meters, so let's try that.
Okay, we can try 80 meters. And what mode do we want to use? SSB processed, all right?
Yeah.
How long are we going to talk? Half the time?
I mean, that sounds a little bit small for me, so let's say 75% of the time.
75%. What type of feeder have we got?
Yeah, looks about right.
58's all right, is it?
Yeah.
How long is it? One thing that is annoying about Excel is that once you've got the box up, you've got to click somewhere to get rid of it. So if you go to a beige box and click, it gets rid of the prompt box. So 20 meters of cable. So now from, did you tell me, I don't think you told me what power you wanted.
I'm just making it up as I go along, so...
50 watts?
Yeah, 50 watts sounds good.
Okay. So what 50 watts says is that you've got to use, you now come out of passing down here on low power, and it says you've got to use the calculated compliance distance to define and manage an exclusion zone. I should point out I'm using version 10A, which hasn't been released yet, as a demonstration, and that is one of the changes in response to requests from people to tell them when they need to use the exclusion zone. Unfortunately, and this is where it gets really good, because we've chosen 80 meters, the Ofcom calculator will not do a calculation for 80 meters because of various limitations. So if I can just, to allow me to carry on with the demonstration, if I can just convert that one temporarily to 20 meters so we get a more meaningful demonstration. I'll come back and explain why there's a limit on 80 meters in a minute. Then what we've got now is we've entered in our station configuration. We've chosen SSB process 50 watt, 75% chat, 20 meters of 58 cable. What type of antenna?
Well, there's a few questions about verticals, so I'd leave it as that for now, and we'll come back to verticals in a minute.
Okay. Average and 65 watts peak, so we have to use the compliance distance. So the compliance distance in this case is 3.4 meters. It is 3.4 meters because it's less than the reactive near field zone, and the Ofcom calculator will not give an answer less than the reactive near field zone. But we already have a vertical separation of 4 meters, so anywhere at ground level, you are compliant.
Okay, thank you. So there's a couple of questions on this, particularly around verticals.
Yep.
That's from Bill Somerville, and also Andrew Thomas has said, I have a button-up vertical for 80 meters. The minimum antenna height would be 0 meters as it's ground mounted. The calculator indicates not valid, and they're asking what they should do to work it out for that.
Either wait till I change the limit or put 0.1 meter in.
Okay, fair enough. Seems very simple.
It's just that it won't allow negative, and I think with the current formula it won't allow 0 either. But if you put 0.01 will work as well, I think. Let me try and see. So if I put in there 0.01, then it's quite happy. If I try and put in, it even gives you 0 as a rounded down number. But if I put in 0, in this version, you'll see it's also happy because I fixed it.
So you talked about 80 meters before and the problems with that. Do you want to go into that a little bit more?
Yes. Now, what happens if you just going to try and bring up a picture. Oh, I'd like to show me that. Yep. if you remember, I said that there was difficulties to do with peak exposures and electrostimulation. So below 10 megahertz, you have to use different types of limits, and also you have to use peak limits, and also you are getting closer, physically closer to quite large antenna structures. So the far field equations that are used to convert from what's effectively power density from your antenna into an electric field, it basically assumes that it uses the power, which is symbol S, is equal to E times H. And to calculate E and H from the isotropic power, it needs to make an assumption about the free space impedance. It's just like on electronic circuits where you have P equals I times V. In fields, you have S equals E times H. And the wave impedance, as it's called, Z, is 377 ohms once you get into the far field of the antenna. But in the near field, there is no simple way of converting from EIRP directly into E and H to allow you to compare with the limits. So what Ofcom have done in the short term is said, until we work out what method we want to use, and they are consulting with us and a number of other people about how to do it, it's only really a problem at HF. We're not going to let the calculator work in those bands while we fix it. But just to be fair to you, we'll give you an extra 12 months to be compliant while we sort it out. So the same thing happens for 40 meters. You'll see it comes up with not valid.
Cool, thank you. Are you able to show a vertical in this calculator, please? Sorry,
Sure.
There are people asking.
There you go. Quarter wave vertical.
So if we set that back to 20 meters, does that give us a result with the 0.0 meters? There we go. Hopefully that will answer your questions in chat. G8YTZ, who is Justin, who you heard from a few minutes ago, asks what the rules are regarding repeaters. I have a TV repeater on top of an elevator room with no public access, and he points out that it's a TV repeater. It's only 3 watts, but it has a lot of antenna gain because it's an Omni. So what are the sort of how is that going to affect him?
Well, basically, he will know what his license condition is for power, and he could use our calculator or the Ofcom calculator, and he will have to calculate his exclusion zone. It's exactly the same. It doesn't matter what it is.
Okay. Dave Miller asks, can the half-wave dipole pack be used for an end-fed half-wave?
No, but we will. Obviously, at the moment, we've only published one pack. We're working on lots of others, but we've managed to get some quite significant changes in our discussions with Ofcom. We've persuaded them. I mean, for example, this change that we've got in here, if I change that to 20 watts, whereby they're now changing their calculator so it, as well as ours, and they're approving us, will give you a green compliance if your power is below 10 watts EIRP and 100 watts peak. That, although we'd always used that, we've only just persuaded Ofcom to agree with us that that is a compliance check. It's called the low power condition. Also, we're working very hard with Ofcom and Public Health England and the Health and Safety Executive with our experts on trying to work out what to do about the peak power limits below 10 megahertz. So there's a lot of work going on, and because of all that work going on, we haven't published many packs yet. There should be a VHF one coming out soon, and we're about to start work on inverted Ls and verticals, because that's another favourite question. And the other one that everybody keeps asking us about is the white stick condynias on the roof.
Okay.
So we will be doing them. It's just that when the rules are changing, and we did 2,700 models for that first pack. We don't want to keep having to redo them all as the rules change and the modelling changes. The biggest difficulty with the modelling we're doing is the segmentation. If you don't get the segmentation right, then the answers are not stable. They don't converge, they diverge. And a lot of people are doing calculations in EasyNet and 4net 2 and that sort of thing. There's nothing wrong with doing them, but you must check your segmentation is stable, because it can vary widely just by changing the number of segments you have in your model. You change nothing else, but your E field and your H field can fluctuate quite wildly at times.
Okay. Bear with me, I'm just looking at the questions. Chris, on that sort of point you mentioned about things still to come, Chris Friel asks if you could summarise the timescales for compliance for the different bands.
Yes, it's November the 18th for 30 megs up, I think it is. Sorry, let me just... Yes, I can, but can we take another question when I look up the answer rather than give the wrong one?
We can indeed, if I read them in time. Bear with me 1 second. Bill Somerville asks, is the position with respect to radials on a vertical clarified yet?
No. We are working on it, but we haven't. I mean, I think it's fairly clear if they're part of the antenna, then it's quite simple. But when you make them below ground, for example, then it's not so clear. There's the answer to that one. This is, again, you haven't seen this. But, this is the new guidance to amateurs that's just about to be published. So it's the 18th of November for frequencies above 110 megahertz. It's the 18th of May for frequencies between 10 and 110. And it's the 18th of November 22 for frequencies below 10 megahertz.
Cool. Thank you. I think this is pretty much the last question now.
The reason, maybe I should just explain, there is something called limb currents that I haven't discussed yet, but they're the reason for between 10 megs and 110 megs, limb currents have a major effect. So they've given extra time to take account of limb currents, which is another requirement of ICNIRP 2020. It wasn't in 1998.
Okay. So yeah, one final question. I think there's a little bit of confusion regarding sort of what counts as a member of the public. So people are talking about if they live in a block of flats, are the neighbours upstairs or downstairs a problem? If you're in the park and someone wanders into your exclusion area, obviously you should stop transmitting, but how about if it's in your garden and your neighbours are out in their garden or something like that? Can you just clarify that? Because I think there's a little bit of confusion around it.
Well, the general public are defined as not radio amateurs and not people covered by the Health and Safety at Work Act. Ofcom have no jurisdiction over people who are employed. So When their new guidance comes out next week, you'll find a quite interesting list of types of people that are not general public, but family, friends, neighbours, lodgers and visitors are all treated as general public.
Okay.
But remember, it's from your antenna, not from your transmitter, the separation.
That's interesting about the family and friends thing, because I do some drone flying, and in that legislation, it is someone who is with you. So if you're flying a drone with a friend, your friend is not considered part of any of the sort of exclusion zones. It's just other people. But you're saying that your family, if someone was in the house with you, you would have to keep them away from the antenna.
That's what they're saying. The general public can include family, friends, neighbours, lodgers and visitors, as well as other members of the general public of all ages. None of these individuals should be exposed to EMF above the general public EMF limits.
Okay, that sounds...
And they can be on both public and private property, including a public footpath, a private residence, including in the garden or on a balcony.
Okay. Chris points out, radio amateurs don't count if they walk into an exclusion zone.
No, we've got, as I said, anybody working with you or the reason for that is that radio amateurs are assumed to know what they're doing.
It sounds very enforceable.
It won't be.
Thank you very much, John. Peter, would you like to say a few words as an ending?
Right, I think I'm back on, Kirk.
Yeah, you are.
Right, well, it's been a fascinating evening. The calculator has certainly answered a lot of my own personal questions. I'm still not clear what the terms mean. I'll be honest with you, but it's a matter of reading up through what's on the RSGB website, I suspect, to try and interpret what all these different terms exactly mean, so that I understand what it is I'm looking at. But I'm very grateful to you, John. I've received 2 or 3 extremely pleasant messages as well, thanking you for your excellent presentation this evening, John. It certainly opened up an awful lot of awareness, in my case in particular, and we've certainly had a lot of questions this evening. I do hope everybody has enjoyed this tonight, and there's no doubt going to be a lot more coming out of the RSGB, I suspect, John, to explain these requirements further, right the way up to the compliance date.
I hope so, and just a couple of interesting statistics or figures, if you like. Since we started doing this, I'm now up at 4,500 emails. The calculator video that we put on YouTube explaining to people how to use it has had 8,500 views. And this presentation, or the earlier version of this, which I gave at the AGM, has had about 3,000 views. So there's plenty of information out there, and we are trying to use videos more and more because people seem to find them easier to follow. So thanks very much for your kind words. And if you've got any time to help us, please volunteer, because there's still lots of work to do. Thanks, guys.
Thank you very much indeed, John. And Kirk, our production manager, IT guru, and everything else on the buttons in the background. Thank you very much indeed for all your support this evening, Kirk.
No problem. Thanks, Peter.
A very good night to everybody. And I think, when will this presentation be up for watching again, Kirk?
Tomorrow morning. It'll be up straight away, but it'll have all the stuff on the beginning and end. So I'll chop it up at some point tomorrow when YouTube lets me.
Chop and tail it tomorrow. Yeah. Okay, so you're going to leave us with your nice music again, are you, Kirk?
I will indeed. It'll be up for another 10, 15 minutes or so.
Okay, that's going. Very good night to everybody. Thank you very much indeed for joining the Radio Society of Harrow's presentation this evening. And a very good night to everybody. Keep well.